Good morning, TKMaths is here. In this video, I will explain to you the concept of permutation and combination, which is a syllabus of CAIE O-Level Ed Maths. So before I begin, you can see on the top the blog address. It's my blog address, and you will find the link of all my earlier made videos on this blog. So according to the syllabus, in permutation and combination, you need to recognize and distinguish between permutation and combination cases, and you need to understand the usage of notation factorial. This expression sign in mathematics is factorial. So we will see what is factorial and how it is applied in which cases. And then the expression for permutation and combination for n items taken r at a time. So for example, total number of items are suppose 10, and I just have to arrange 7, or I have to select 7. So how we will deal those type of cases. And then simple problems where arrangement and selections are used. What is excluded from the syllabus is that the cases with certain repetition, like I said, I have digits 1 to 3, and how many numbers with these digits I can make. I can't use one more than one time. So this is called repetition. So there is no repetition. And I cannot arrange object in a circle. It has to be in a line. Or any problem which has both permutation and combination involvement in it. So these type of cases are excluded from the syllabus. Okay, so basically you need to know these concepts in this chapter. Basic counting principle, factorial, permutation and combination. And in permutation, are objects from n different objects. I just gave you example. Once again I can give you. For example, you have 10 books and you have to put only 7 on the shelf. So in how many ways you can select those books to put on the shelf. Or combination, permutation with restriction. For example, I give you 5 digits and I said how many numbers, even numbers I can make, right? So these type of restriction may be applied. When we say permutation order, it means those cases where order is important. For example, if students are called out for the awards, first, second, third position. So if I call a student A, B, C, it means A got first prize, B got second prize, C got third prize. But if I called B, A, C, it means B got first prize. So here the order is important. So A, B, C, B, A, C, C, B, A, all these are different order, because if I'm calling out the name of the first prize winner first, then second, then third, so order is extremely important. Whereas in combination, order is not important. For example, I am selecting 3 people from the class and I'm calling them out to take them for meeting or somewhere. So if I say I want a student ABC out of the class, or if I say student BAC, so it doesn't matter in which order I call out the name, because the same 3 people will come out. So there are certain cases where order is not important. So in this chapter, permutation and combination, we need to know the concept of these type of things. So let's start with a basic counting principle. So what is a basic counting principle? If I will just explain the definition here, it may not make sense to you. So let me start explaining with the help of a question. So for example, there are 4 questions, right, in your quiz. And each question has 2 options, true and false. So in how many possible ways you can give the answer, right? So let me explain with the help of tree diagram. So from the first question, you may pick up true or false. Now, for example, you have picked up true from the first question. Then from the second question, again, you can pick up true or false. If somebody has picked up false from the first question, again, he will also have 2 options in the second question, true or false. Now, suppose again I have picked up true, or you have picked up true. So from the third question, again, you have the option true, false. So somebody who has picked up true from the first question, true from the second question, so again he will have two options in the third question, right? So it makes sense. So similarly in the fourth question. So if I see or you see, the possible ways to answer this question is maybe from first true, second true, third true, fourth true. So one way to answer the question is true, 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 true. Or maybe another way, true, 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 false. Or true, false, true, true. True, false, true, true, false. So how many ways are there? If I see the end of this, it will give me a better idea. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Because you see, all this will take you back up here. For example, if I look at this branch, it will take me up here. If I look at this branch, it will take me up here. So I have 16 ways to answer. So if I try to find out number of possible ways with the help of this diagram every time, it will become very tedious, very time consuming. So what is the way to figure it out? So the best way is, first question has two options, second question has again two options, third question again. So there are 4 questions and each have two options. So it means you can do 2 into 2 into 2 into 2 is equals to 16. So this is possible answers. So now if I tell you the definition for this, I can say if questions I consider as a task, I have 4 tasks to perform and the number of ways each task can be performed is, there are 2 ways, right? So each task can be performed by 2 ways. So if I want to find out in how many ways I can answer, I just have to multiply number of ways of each task. I'm repeating, number of ways of each task. So when I'm doing it here, there are 2 ways to answer question 1, 2 ways to answer question 2, 2 ways to answer question 3, 2 ways to answer question 4. So if I multiply all of them, I will get possible number of ways. Now for example in the fourth question, if there are 3 options, for example true, false or none, right? So then I could write here 2, 2, 2, 3. So you always multiply number of ways each task can be performed and then you get the total number of answers. Okay, so now let's see next thing. Similarly, let me take another example. Suppose I'm tossing a coin 5 times. Now what are the possible outcome for each toss? If it is a coin, then there are 2 outcomes only, head and tail, right? So when I'm tossing the coin first time, there are 2 options, head and tail. Second time, again 2 options. Third time, again 2 options. Fourth time, again 2 options. Fifth time, again 2 options. So rather than counting all these, for example, first one is head, 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 or head, 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 tail. So these are possible ways of getting the result after the toss. So rather than counting how many possible ways I have to get the result, I can simply do 2 into 2 into 2 into 2 into 2 because there are 5 tosses and each toss is my one task and each toss give me 2 outcomes. So I am here multiplying the outcome or the ways of each task. So this is giving me total 32 outcomes. So I can write 2 power 5. So that I can do only in case when the outcome of each task is same. Okay, so this is a basic mathematics. So now let's see what is a factorial. Okay, so in mathematics, this symbol is factorial and it is in the calculator also. Now what is the meaning of this symbol? If it is written 5 factorial, it means 5 into 4 into 3 into 2 into 1. If it is written 7 factorial, it means 7 into 6 into 5 into 4 into 3 into 2 into 1. Okay, let me write one more thing here. Okay, so I've just added this line here. For example, 7 factorial, and I write it as 7 into 6 into 5 factorial. So it's fine, there is no problem. You know why? Because 5 factorial mean 5 into 4 into 3 into 2 into 1. So factorial you can stop anywhere on the way, because at times you need it to cancel out few terms. So you need to understand this and this is same thing exactly. Now writing it generally, if it is n factorial, n minus 1, n minus 2, n minus 3, and go back till 1 factorial or 1, right? Because you see 7, this is 7 minus 1, 7 minus 2, 7 minus 3, 7 minus 4. So exactly same, n minus 1, n minus 2, n minus 3, and so on till you go to or reach to 1. So what is n? N is a non-negative integer. Remember one thing, 0 factorial is 1 and 1 factorial is 1. I'm not going into the proof of this, but if you put on YouTube why 0 factorial is 1 and why 1 factorial is 1, there are very good examples, good explanation. So you can check it from there if you have an inquiring mind. Okay, now let's see an example of the application of factorial. For example, how many 4-digit numbers you can form using these digits? So the digits are 1, 3, 5 and 7, and you want to make 4 digits number, and none of the digit will be repeated. Okay, now if you see these 4 blanks, at the first place I have 4 options and I can put any one here. Then once you will put 1 digit here, then you will have how many options? 3 options left. So you can put any one here. Then how many options are left? 2. Then how many? Last one. So that's why it is 4 into 3 into 2 into 1. Or simply you can write 4 factorial 24 ways. Now why do we multiply here? I will just build up this concept in a while, and I hope it will make sense to you. Okay, this one I've explained. So let me take next concept. Okay, so now it is permutation. What is a permutation? A permutation is an arrangement of object in a definite order, right? So let's see this through different examples. In how many ways can 3 letters A, B, C can be arranged, right? So here I have just taken example of a small letter so that I can explain it to you. So A, B, C, A, C, B, and so on. And I gave you example earlier that if A, B, C are name of students who have to go on this stage to receive the prize of first, second, and third, so order does matter, right? So that's why order is very important, and you have to understand when you will read questions that either order is important or not, because when order is important we use permutation. Now in your calculator you will see this button, right, which is written like this basically. Now what does this mean? Here I have written 3p3. It means out of 3 I have to select 3 cases. So when it is 3p3 we can write it as 3 factorial. I'll explain you why this can be written like this. Now for example, I gave you example of 10 books in this shelf. I have to put 10 books I have, and I have to select, for example, 7 books to put in the shelf, right? If I put it in the calculator, what will be the answer? Let me check. Okay, so the answer is 604,800. So how we will do it without a calculator? Now this is very important. NPR, N is representing total number of items you have, and R is representing that you have to select R items. For example, 10 books and you have to select only 7. So without calculator, how do you do it? It means n factorial divided by n minus r factorial. So in this case it will be 10 factorial divided by 10 minus 7 factorial. 10 minus 7 factorial is 3 factorial, and 10 factorial can be written as 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 factorial. Why did I stop here? I just want to cancel them out. So then I will multiply all of them and it will be equals to this, right? So permutation you apply when order is important, and this you apply when you have to select few items from the total number of items. If it is same that there are 3 items and you have to select all 3, so you can use straight away factorial, or you can use this also. It's fine. Let me show you in the calculator where is this button. So if you see, because I have right now this calculator only, if you see above the sign of multiplication, it's written NPR, and above the division it is written NCR. This is in yellow, so you use it with the help of shift button. Okay. So now another example. In how many ways can a judge award first, second and third prizes in a contest with 9 participants, right? So there are total 9 participants and 3 people will get award. So in how many ways number of people can be selected out of those 9 people? So 3 you have to select. So it's basically 9p3. So straight away you can put this in the calculator. You will press 9, shift that button and then 3. Okay. So you will get the answer 504. And if you have to show working, then it will be 9 factorial divided by 9 minus 3 factorial, which is 6 factorial, and then you can write 9 into 8 into 7 into 6 factorial, cancel it out, right? Now let's see the permutation case with restriction. So right now we have seen what simple permutation means and what is permutation of R object from N objects, selection of R objects from N object. Now if it is a case of restriction and we have to solve the question, we always settle the restriction first, right? So for example, the question is how many numbers between 2000 and 5000 can be made from the digit 1, 2, 4, 5, 7 and 8. Okay, so you have how many digits? 6 digits. Okay, and you have to make 4-digit number. So let's see the gaps. 1, 2, 3, 4. Now the point to understand here is that if the number has to be between 2000 and 5000, then the first digit can only be 2 or 4. Yes or no? If I will have the first digit 2 and any other digit out of the remaining 5 digits, it will be 2000 something. And if I have the first digit 4 and then any digit out of the remaining 5 digits, it will be 4000 something. So number 2000 something and 4000 something is in between 2000 and 5000. So because on the first place I have 2 options and I can select one option, I'm writing 2p1. So I have settled this restriction. Now 1, 2, 3. 3 digits are left, okay, to make 4-digit number. And how many digits are left here? 5 digits, because out of 4 and 2, 1 has settled at the first place. So remaining 5 digits are left and I have to select 3 digits out of it. So I will write 5p3 and then multiply. Now mostly students ask why there is multiplication symbol, right? So let me explain you or build this concept with the help of one example in detail so that you can understand wherever we are multiplying what is the reason behind it. Okay. Now for example, you have 5 boys and 3 girls students and you have to make a group of 5 students in which you have to select 3 boys and 2 girls. I am repeating, from the students, students are consisting of 4 boys and 3 girls and you have to make a group of 5 students in which there should be 3 boys and 2 girls. So in how many ways you can make a group of 5 students? right? So now let's see. The 4 boys I have, for example, are A, B, C, D, and the 3 girls I have are A, B, C, small letters, right? So that you can understand. Now from the 4 boys, I have to select 3 boys. In how many ways I can select them? So I can figure it out 4C3, because like I said, when I'm selecting boys, either I called ABC or BAC. It is same thing. So that's why order is not important. That's why I'm using combination, right? 4C3. Okay, so there are 4 ways to select 3 boys out of 4 boys. Here I have done for you. So one possibility is ABC, other possibility is ABD, then BCD, and then ACD. So these are the 4 possibilities: ABC, ABD, BCD, and ACD. So you can see none of them is repeating. Okay, so the selection of 3 boys out of 4 boys can be done in these 4 ways. Okay, now from the 3 girls, I have to select 2 girls. In how many ways I can select them? 3C2. It means there are 3 ways. What are those? Girl AB, BC, or AC. There is no other way, right? Now how many students I have to select for the group? 5 students. So now let's see the concept here. If I select this group of boys ABC, I can select this group of girl with them. So I will have a group of capital ABC, small ab. So this will be one group. Or I may have ABC with this group of girl. So I will have capital ABC with small bc. Or I can have capital ABC with the small ac. So it will be this group, right? So with these boys, with this group of boys, I can select anyone. So I will get 3 groups from here, either this one, or this one. Similarly, with this group of boy ABD, I can select this group, or this group. So again, I have 3 options with this. Same goes with other 2 groups. So if you see how many 5 groups I can make with 3 boys and 2 girls are altogether 3 plus 3 plus 3 plus 3. Yes or no? So 3 4s are 12. So I can say 4 times 3 is 12. That's why we multiply it. That's why we do 4C3 multiply by 3C2. You get my point here? Why do we multiply? This is the simple reason for that. So I hope you understand with this example why do we need to multiply the cases. And let me connect right now here in which case we add the groups. Now for example, I have 5 boys and 6 girls and I have to make a committee of 4 members, right? And I'm saying the members should be from the same sex. So either the members are all boys or the members are all girls. Okay, so now how many boys I have? 5 boys, and I have to make a committee of 4 members. So I can take 5C4. Okay, 5 boys and I have to select 4 out of them. So how many ways I can select them? 5 ways, and I have shown here ABCD, ACDE, BCDE, ABDE, and ABCE, right? So you will see none of them is repeated here. Similarly, out of 6 girls, I have to select 4 because the committee is of 4 members and it should be same sex, mean same, either boys or either girls. So there are 15 ways I can select girls out of 6 girls, which is all listed here, you can see. Now you see here, I don't need to multiply this by this. Sorry, I do not need to connect this by this. Why? I'm not talking about 4 boys and 4 girls. I'm talking about 4 boys only. So this is making one complete group. So that's why I have here 5 and I have here 15 possibilities. So altogether 20 possibilities of making a committee of 4 members which have the same sex. Whereas in this case, I was selecting a group of 5 students which has 3 of this and 2 of this. So there were 3 possibilities with this group of boys, 3 possibilities with this group of boys. So that's why I was multiplying here, because it was 3 plus 3 plus 3 plus 3. So rather than writing it like this, I was writing 4 times 3. So now you understand in which case we multiply and in which case we add. One more thing for your understanding, maybe somebody mentioned it to you. If you see here, 4 is written here. Now this 4 is actually representing the actual number of members you need in a committee. Whereas in this case, if you see, you did not need group of 3 students, you need group of 5 students. So if you add these two, 3 and 2 in your mind, it is equals to 5. Then multiplication comes here. So this is also one way of cramming basically, but concept I have already explained to you. So with this I will end this video, and in the next video I will take more example of permutation and then combination I will explain, and then past paper. Thank you very much for watching this video. If you like it and you think you have learned something from it, so please press like and subscribe button. Share it with your friends, they may also learn something from it. Your positive constructive feedback which can help me make more meaningful videos would be appreciated. Thank you. Take care. Bye bye.